Hello, dear student. Welcome to NCERT Reader. And then the continuation topic, we are having the heat conduction. This is rapid revision for JMain and advanced you are watching here. So in this segment, you'll be learning that what is the heat conduction and heat transfer method. We have three kind of heat transfer method. One is heat conduction, another is heat transfer by convection, and the another one is radiation. So in our topic, mainly conduction is and radiation is the major topic which is there given. So हम लोग इसी कंडक्शन के बारे में इस वीडियो में इसको देखेंगे, किस तरह से आपको बेसिक कंसेप्ट को ध्यान में रखना है और कंडक्शन से रिलेटेड किन किन चीजों का आपको क्वेश्चंस में जो है नीडेड है कंसेप्ट, और उसको कैसे आप इम्प्लीमेंट करेंगे। लेट्स सी इट इज। सो कंडक्शन जब भी होगा तो वो सॉलिड में होगा, सॉलिड के केस में ही कंडक्शन होगा। तो दिस यू कैन रिमेम्बर दैट इट विल हैपन इन सॉलिड। और जब भी कंडक्शन होगा तो इसमें ये भी चीज ध्यान रखेंगे कि हीट ट्रांसफर जब भी इस मोड के थ्रू होगा, कंडक्शन के थ्रू होगा, तो जो मीडियम में जो भी पार्टिकल्स है उस पार्टिकल का मूवमेंट नहीं होगा एक जगह से दूसरे जगह में। ये चीज ध्यान रखना है। दूसरा पॉइंट जो है वो ये चीज है कि पार्टिकल का जो मीडियम में जो पार्टिकल्स है उस वो एक जगह से दूसरे जगह ट्रांसफर नहीं होंगे। जो नेक्स्ट कंसेप्ट है इसमें आपको समझने के लिए वो है स्टेडी स्टेट। स्टेडी स्टेट का मतलब ये है कि जब हीट फ्लो जो है, रेट ऑफ हीट फ्लो जो है वो आपको कांस्टेंट हो जाए। दैट इज द मीनिंग कि जितना हीट इन हो रहा है और जितना हीट आउट हो रहा है वो अगर इक्वल हो जाए तो उस केस को हम लोग स्टेडी स्टेट बोलते हैं। तो बाय डिफिनीशन अगर आप देखें तो व्हेन हीट कंडक्शन टेक्स प्लेस across rod of certain material, then the state at which the each cross section of the rod is at constant temperature, which is different for the different sections. Which is different for different sections का मतलब ये है जैसे जैसे आप डिस्टेंस बढ़ाएंगे तो वो जो है टेम्परेचर जो है वो डिक्रीज करते जाएगा, तो वो दैट इज डिफरेंट। बट व्हेन इट इज कांस्टेंट देन इट इज कॉल्ड एसटीडी स्टेट इज रीच्ड। तो यहाँ पे एक हमने कंडक्टर को लिया है जिसका दो टेम्परेचर मेंशन है, T1 एंड T2। T1 इज द हायर टेम्परेचर एंड T2 इज द लोअर टेम्परेचर। ऑब्वियस सी बात है, हीट का जो फ्लो होना चाहिए कंडक्शन के कारण से जो भी पार्टिकल्स हीटेड होगा, नियर बाय पार्टिकल्स को हीट ट्रांसफर करेगा और नियर बाय पार्टिकल नेक्स्ट नियर बाय पार्टिकल को, और इस तरह से एक जगह से दूसरी जगह हीट एनर्जी जो है आपको ट्रांसफर होना शुरू हो जाएगा। तो अगर हम मानते हैं कि एक्स डिस्टेंस पे एक क्रॉस सेक्शन को हम एज्यूम कर रहे हैं और डीएक्स जस्ट थोड़ा सा एलिमेंटल शिफ्ट होने के कारण से डीएक्स डिस्टेंस पे इससे अगर हीट फ्लो क्यू हो रहा है, तो रेट ऑफ हीट फ्लो अक्रॉस एनी सेक्शन अगर लिखना हो, दिस इज इंपॉर्टेंट कंसेप्ट यू हैव टू अंडरस्टैंड हियर कि रेट ऑफ हीट फ्लो अक्रॉस एनी क्रॉस सेक्शन क्या होगा। दिस रेट ऑफ हीट फ्लो अक्रॉस एनी क्रॉस सेक्शन, इसको हम लोग एच से डिनोट करते हैं। दिस इज dq by dt एंड इट इज माइनस ऑफ ka dt by dx। यहाँ पे के क्या है कि थर्मल कंडक्टिविटी है जो मटेरियल पे डिपेंड करेगा। जैसे अगर आप मटेरियल एजी रखते हैं, कॉपर रखते हैं, एल्यूमिनियम रखते हैं, तो एजी का सबसे ज्यादा के वैल्यू होगा, कॉपर का देन एल्यूमिनियम का होगा। तो दिस इज मेनली डिपेंडिंग अपॉन द मटेरियल। एंड dt by dx क्या है? इट इज कॉल्ड टेम्परेचर ग्रेडियंट। टेम्परेचर ग्रेडियंट का मतलब है रेट ऑफ चेंज ऑफ टेम्परेचर विथ रिस्पेक्ट टू डिस्टेंस। तो जैसे जैसे आप डिस्टेंस को चेंज करेंगे, दिस dt means change in temperature with respect to distance. That is the meaning of temperature gradient here. Now इस इस dq and dt को हम लोग हीट करंट भी बोलेंगे। sometimes it is ask you what is heat current, that you need to understand it is asking you dq and dt, or it is also the same meaning rate of heat flow, that is also same meaning। हीट फ्लो का रेट जो है एक्चुअल में क्या हीट एनर्जी है, और फ्लो का रेट को हम लोग एनर्जी पर यूनिट टाइम कहेंगे, और एनर्जी पर यूनिट टाइम जो होगा वो पावर होगा। तो दिस हीट करंट व्हाट हियर वी आर हैविंग इज एक्चुअली पावर। जो पावर आपको हीट के कारण से एक जगह से दूसरे जा रहा है, वो पावर का वैल्यू क्या होगा, वो कैसे आप कैलकुलेट करेंगे इन टर्म्स ऑफ थर्मल कंडक्टिविटी, एरिया ऑफ क्रॉस सेक्शन एंड पोटेंशियल टेम्परेचर ग्रेडियंट। Here minus sign shows that once you are moving from higher temperature to lower temperature, then temperature is decreasing। तो dq और dt जो होगा वो आपका जो rate of flow of heat होगा, that will be dt का वैल्यू जो है आपका, dt means change in temperature, it is decreasing, that is why it is minus here it is written। So minus का meaning only है कि temperature decrease कर रहा है, that is the only meaning minus। and dq by dt you can write ka dt by dx. यहाँ पे जो इम्पोर्टेंट इसमें टर्मिनोलॉजी आएगा या जो इम्पोर्टेंट कंसेप्ट है वो वन बाय वन करके हम लोग देख रहे हैं। पहला है एसटीडी स्टेट जब भी रीच हो जाएगा उस स्टेट पे रेट ऑफ फ्लो ऑफ हीट जो होगा वो सेम होगा अक्रॉस एनी क्रॉस सेक्शन। तो रेट ऑफ फ्लो ऑफ हीट क्या होगा dq by dt एंड इट इज व्हाट ka T2 minus T1 by x dx it is. So T2 minus T1 माइनस साइन होने के कारण से T1 minus T2 और dx जो है अगर हम इसका कंप्लीट लेंथ की बात कर ले तो यहाँ से यहाँ तक का लेंथ जो है वो L है। तो इसमें जो एसटीडी स्टेट आने पे जो रेट ऑफ फ्लो ऑफ हीट होगा that flow of heat you can write like this ka T1 minus T2 by L, where you can understand that T1 is greater than T2. This I have already assumed previously that T1 is greater than T2. और दूसरा टाइप इंपॉर्टेंट रिजल्ट में ये आएगा कि कभी कभी आपको दो टेम्परेचर डिफरेंस दिया हुआ रहेगा, यानी कि हायर टेम्परेचर दिया हुआ रहेगा, लोअर लोअर टेम्परेचर रहेगा, और वन एंड यानी हायर एंड से इस बीच में कहीं पे भी एक जगह टेम्परेचर होगा जो टेम्परेचर हमें कभी पूछ दिया जाएगा व्हाट विल बी द टेम्परेचर। सो दिस टेम्परेचर विल बी जो हायर टेम्परेचर है उससे माइनस होगा T1 minus of T2 divided by L times of X. This is the way you can calculate the temperature. I am just writing the formula of which directly you can use for the JEE point of view. We can go for the explanation and all and derivation because we have very less span of time. This is just for revision point of view. So just I am writing the formula. So ये formula आपके माइंड में रहना चाहिए जब हम लोग इस टाइप का थर्मल कंडक्टिविटी में हायर एंड टेम्परेचर से एक्स डिस्टेंस पे टेम्परेचर को निकालने का हो तो उसमें हम लोग इसको यूज करेंगे। फिर नेक्स्ट जो कंसेप्ट है इसमें आपको थर्मल रेजिस्टेंस क्या होगा। तो थर्मल रेजिस्टेंस जिस तरह से हम लोग इलेक्ट्रिक करंट चैप्टर में पढ़ रखे हैं कि रेजिस्टेंस कैसे निकालते हैं, उस केस में रेजिस्टेंस निकालने का फॉर्मूला आपके पास एक तो ओम्स लॉ है और दूसरा रेजिस्टेंस जो उसका लेंथ और एरिया क्रॉस सेक्शन होता है उसके बेसिस पे है। इसको हम लोग L बाय सिग्मा टाइम्स ऑफ ए भी लिखते हैं। तो ये सिग्मा या रेजिस्टिविटी के टर्म में रेजिस्टेंस लिखने का तरीका है जो हम लोग करंट इलेक्ट्रिसिटी चैप्टर में पढ़े हुए दिस वन। इसी रिलेशन के बेसिस पे यहाँ पे आप कंपेयर कर सकते हैं। मान लेते हैं कि ये क्रॉस सेक्शन जो है ये एरिया ऑफ क्रॉस सेक्शन ए, इधर का भी एरिया ऑफ क्रॉस सेक्शन है, यहाँ का टेम्परेचर T1 है, यहाँ का टेम्परेचर T2 है और इस मटेरियल का थर्मल कंडक्टिविटी K है। And let's suppose the rate of flow of heat from one end to another end it is dq by dt, dq by dt। तो ये चीज दिमाग में रखना है आपको कि जिस समय एसटीडी स्टेट पहुंच जाएगा when the STD state is reached, by that time what happen? So in STD state this is length of the rod I am considering here L. So at STD state dq by dt, this is rate of flow of heat, it will be K and then area of cross section, then T1 higher temperature minus lower temperature by L value. So ये एसटीडी स्टेट पे जो है आपका यानी कि dq और dt जो होगा यहाँ से जो हीट इन हो रहा होगा और यहाँ से जो आउट हो रहा होगा, सॉरी, ये आपका एसटीडी स्टेट पे सेम रहेगा। दैट इज द मीनिंग हियर आई हैव dq और dt is Ka T1 minus of T2 and divided by L। अगर इस रिलेशन को हम एक और तरीके से लिखना चाहे तो हम लिख सकते हैं इसको T1 minus of T2 divided by L by K times of A। इसमें कोई प्रॉब्लम नहीं होगा, बट इस रिलेशन को लिखने के पीछे का लॉजिक यह है कि थर्मल रेजिस्टेंस को डिफाइन करना। हाउ वी कैन डिफाइन द थर्मल रेजिस्टेंस? यू कैन कंपेयर विद द normal concept what we know in electricity, it is potential difference divided by resistance. This is the current we have according to the Ohm's law. This is the electric current we have. This dq dt is nothing but it is heat current. This is heat current, or simply we say power or rate of flow of heat. That is the meaning same. It is heat current, rate of flow of heat it is, or power it is getting transferred from one point to another point. That how we can write in terms of temperature difference and length and the thermal conductivity and area. तो इसमें ऊपर का जो डिफरेंस है आपको ये टेम्परेचर डिफरेंस है T1 minus of T2 यहाँ पे हमने T1 माइनस ऑफ T2 लिया था, जो मेन फॉर्मूला है उसमें आप देखिए कि यहाँ पे माइनस ऑफ के ए डी टी बाई डी एक्स लिखा। माइनस साइन का मतलब है यहाँ पे कि टेम्परेचर डिक्रीज करेगा, तो माइनस को जब आप लिखेंगे और dt को आप लिखेंगे T2 माइनस ऑफ T1, तो वहां पे T1 वाला टर्म प्लस हो जाएगा और T2 वाला टर्म माइनस हो जाएगा। दैट इज व्हाई आई हैव रिटन हियर दिस T1 माइनस ऑफ T2 डिवाइड बाय L बाय के ए। और इसको हम लोग इस तरीके से लिख सकते हैं कि जो हीट करंट यहाँ पे हो रहा है आपका हीट करंट, or simply dq by dt. This we can write like this is what is T1 minus of T2, higher temperature minus lower temperature, divided by R thermal. This is called your heat current. Heat current. So sometimes if it is given to you, the question is asking you like this, that what will be the thermal resistance over here it is. So we can say that this is the thermal resistance. That thermal resistance is length divided by K times of A. So this is what we can write here. It is thermal resistance. Thermal resistance. So it is thermal resistance. We have this is RTH, and this will be, it is length by K times of A. K is thermal conductivity, A is area of cross section, and L. If you compare this relation with this one, you can see here length by area times of sigma. So what the sigma role plays in that it is over there electrical conductivity. Here it is thermal conductivity. Only thing is that difference. So this we have to remember, and then on the basis of that, we can compare that what is, sometimes it is asked you what will be the thermal resistance if the two conductors are connected like in series or in parallel combination. So we can have that kind of questions also. If suppose composite rod is given to you, what kind of composite rod will be there? Let's see. If composite rods are given to you, so in composite rod, first case we have series. So whenever we have series connection, so in series connection means one conductor, I am considering this kind of conductor it is, and it is joined by the another conductor. Let's see, this I am considering another conductor. And area of cross section of both the conductor, it is same. So what the area of cross section here it is same for both the conductor. So area of cross section is not getting changed. And here I am considering the first conductor has to be the having length L1. This is having length L1. And the second conductor is having length L2. This one. And let's suppose area of cross section here A, here also A it is. There is no any change in area. This material is of thermal conductivity K1, and this material is of thermal conductivity K2. And here one end having temperature T1 and another end having temperature T2. And let's suppose what is the common temperature here. This is your common temperature T, where the junctions is there. So in case of Ohm's law also we have two resistance over there. So how to find that common potential over there, or the point where the two resistance are connected? In the same manner you can find here temperature also, but temperature will be depending upon length, thermal conductivity, and the area of cross section. That common temperature, how we'll find that also we see. So in case of series combination, if it is in STD state, so in STD state, what we can see here in STD state, that resistance we can write, this resistance will be, well, suppose I am considering this resistance is R1 and this resistance is R2. So it is in R1 plus R2. This will be the STD state condition, that it same heat flow dq by dt will be there. What the dq by dt here, it is dq by dt, and the same dq by dt will be there in this also. Here also we have dq by dt. So, and in STD state condition, what the dq by dt, here it is same here also. So resistance we can write R is equal to R1 plus R2 in the series combination. How to write the resistance thermal? It is L by Ka. So to write R1, we can write R1 as this. R1 will be this simply in terms of, it is L1 divided by K1 times of A. Similarly, I can write R2. R2 I can write here. It is L2 divided by K times of A. K for R2 it is K2. So after writing this one, you can write here it is. So this is L1 by K1 times of A. Then we have this L2 by K2 times of A. And if it is third resistance or third conductor will be there, the same manner we can add like this L3 by K3 divided by A. The same manner you can write. Where if you go for the simplification over here in this one, so you'll be getting this is to be L1 plus L2. This is the total length. For this, I am writing this is the total length here it is. And if K is the thermal conductivity of the combination given here, and A is the area of cross section. So this will be the resistance of series combination. For this one, I can write total length divided by thermal conductivity and A. So once you see the simplification of this one, so what K here it is, K is, this is called effective thermal conductivity. Effective thermal conductivity. And this effective thermal conductivity for the same area, how we can calculate for same area of cross section. If it is same area of cross section, then how we can calculate this thermal conductivity effective is. So for finding that thermal conductivity, we can have this formula. So this is K is equal to, it is L1 plus L2 plus so on. It is if more numbers of conductor or more numbers of metal here added over there, in that case, this will be length of Ln, length of Nth, and then we can have this as L1 by K1 plus L2 by K2 plus L3 by K3, and so on. It is Ln by Kn. So this is the way you can write the thermal effective thermal equivalent. What I have written here it is. This is for that. So when we have only two L1, L2 only, so we use L1, L2, L1 plus L2 by L1 K1 plus L2 K2. So for two rods are connected over there, and in that case, how we can write this thermal conductivity, you can see here. So for that, how you can write thermal conductivity, you can see. So for L1 and L2, that you can write here K equivalent will be just L1 plus L2 divided by L1 by K1 plus L2 by K2. And if you simplify this, it will be, we have K1, K2 in numerator. So it is K1, K2 in numerator. It is L1 plus of L2 divided by, it will be K2 times of L1 plus K1 times of L2. So this will be the K equivalent when two rods are joined over there. So by that time, you can use this to be the K equivalent over there in terms of that K1, K2 and L1, L2, because we know that area of cross section is same here. So this form you can use. And another special form here you can use also. A special case is what? If suppose equal lengths are given to you, like L1 is equal to L2. Let's suppose I'm considering L. So in that case, if length will be equal, so here we have 2L in denominator also, L will cancel out. So what you will get in numerator 2 times of, so what will be the K equivalent by that time? It is 2 K1 K2 divided by K1 plus of K2. So this is the special case. You can say this is harmonic mean of K1 and K2. This is the case when series two rods are joined in series, and you can say that at a steady state you can find the thermal conductivity of the equivalent one, that will be 2 times K1 K2 by K1 plus K2. And this you can compare with the capacitor value. When the capacitor are connected in series, in that condition you will be having this type of equivalent capacitance. In the same manner you can write the thermal conductivity. Now the second point in this one, this is the first important point when we have the series. So how you can find the resistance over there, how you can find the thermal conductivity of equivalent combination. And then the second part here, it is what will be the temperature at the junction point. So to write the temperature at the junction point, you can have, this is temperature temperature of junction. This is the next important point related with this series combination, temperature at junction. So that temperature, if I'll consider T1, so it is just this formula. You can write K1 by L1 times T1 plus K2 by L2 times T2 divided by, we have K1 by L1, then we have K2 by L2. So this is the temperature at the junction. This I have written on basis of dq and dt format. It will go for there only. So you can have T1 and T2 temperature, both K1 L1 and K2 L2. Here it is. In terms of that, you can find the junction temperature. So what is the junction? Where we have L1 and L2 are attached. That is the meaning of junction. So if it is, if the all geometrical dimensions are same, like L1, L2 are same, in that case, what will be there? L1, L2 are same, then L1 will be taken as common here also. Here it will get cancelled out. So in numerator, we have K1, T1 and K2, T2 divided by K1 plus K2. So if L1 is equal to L2, if it is supposed to be L here, so what will be the junction temperature? By that time, it is K1, T1 plus K2, T2 divided by K1 plus K2. So this is one way to calculate when the dimensions are same, like area of cross section. I have assumed earlier that it is same, and length here, if I am assuming same, then in that condition you can find the junction temperature to be like this. So these are the two forms which you have to remember. What if it is for identical, if it is for same kind of geometrical, what you can say dimension, then this will be the junction temperature. Otherwise, this will be the junction temperature. Or this is the K equivalent for series combination. You can apply this formula wherever it is needed, 2, 3, 4, or n times. You can use this to be the direct one in case of series combination. So two things you have to remember, then only you can solve. Next, whenever it is connected in parallel. So first case, we have seen that series combination. Next, we have parallel combination. So when parallel combination will be there, in that case, there is one rod here. If it is connected between two ends, here one end, this length is considered, length will be same only, and the another rod I'm considering, this is the another rod, and maybe that area of cross section here, it will be different. So here, if I'll consider that area of cross section, for first one it is A1, and the first second one it is A2. This is the area of cross section. This is having thermal conductivity K1. Here it is thermal conductivity K2, and T1 is the temperature of this end, and T2 is the temperature of this end. And heat, this T1 is higher temperature and T2 is lower temperature, if it is there, and L is the length for both. So what is the temperature difference? In this case, you can see what the heat is going in this first conductor. It will be dq1 by dt. And what the heat is going in this second one, it is dq2 by dt. Both are having different heat. Heat may be heat here, what we have length same, it is area of cross section. If it is same, in that case we have same heat will flow, but here we have different area of cross section. So because of the length is same, so different area of cross section. So in this case we have dq and dt different. So whatever the dq and dt is coming at this end, it will it is coming at this end and it is getting out at this end. So we have one end is dq and dt, which is the what you can say heat flow, dq and dt. So this dq and dt is getting dq and dt is heat current. So it is getting in two parts. One first rod it is dq1 by dt, and the in second rod it is dq2 by dt. So what you can write here is this is dq1 by dt, and the second one it is dq2 by dt. So this is the same thing you have learned in the full that Kirchhoff's law in the current electricity, that current is getting branch, then junction law it is the same. It is heat current, dq and dt is nothing but heat current only. So it is getting in one branch dq1 by dt, and another branch it is dq2 by dt. And if resistance will be written like, then parallel combination, we know that 1 by R1 plus of 1 by R2. And this is what we can say for equivalent. We have, this is the equivalent one. So for equivalent, what is the thermal conductivity K, and what is the area of cross section? It is A1 plus of A2 and divided by the length it is. So what is the thermal resistance for this one? So it is having, R1 is having K1 A1 divided by L. Then what is for R2? It is K2 A2 divided by L. Here we know that resistance, whenever we write resistance thermal, it is L by K times of A. So I have written on the basis of this one here. It is 1 by R1, so L is in denominator and then Ka will go in numerator. For R1 it is K1A1, for R2 it is K2A2. Now L is common in all here, so L can be removed. So here K is the effective thermal conductivity of the combination setup given to you. That what the combination is given to, for that K will be the effective. So you can see here this A1 by A2 will be in denominator. So what is the thermal conductivity? Here you have K1 A1 plus K2 A2 divided by A1 plus of A2. See the difference? This is a parallel combination. And what we have when we have the dimension of same length and area, then this is the this is the common. Actually, this is the thermal conductivity in this case. So thermal conductivity in this case is L1, L2, L3 to Ln and divided by L1 by K1, L2 by K2, L3 by likewise it is. But in case of parallel combination, you can see length is same here. So area of cross section is different. So for that, you can apply that thermal conductivity is this. Now, if I suppose to assume that if A1 is equal to A2, if A1 is equal to A2, what you can say, if A1 is equal to A2 and assume it as A it is. So in that case, what A1 and A2, it is A and denominator we have 2A, so A get cancel out. So this K will be simply K1 plus K2 by 2. This is nothing but the arithmetic mean of K1 and K2. So when we have equal length, equal area in parallel, you can use direct this one. When we have equal length, equal area in series, then you can use 2K1, K2 by K1 plus K2. These are the method to find the K equivalent. So this is the thing, we can have the thermal conduction over there. And just now we have remain with the Stephen's law and then Newton's law of cooling and Newton's law of cooling, and these are Newton's law of cooling and thermal radiation over there, that heat transfer radiation, and wind displacement law. So these are the topic which we covered in the next videos. I hope it is clear for this video. I have just completed the conduction only, and in conduction, what are the major topics, major thing you have to understand, and how you can find out the resistance thermal, then the heat current over there or rate of flow of heat it is, and what is temperature gradient, what is thermal conductivity, what is thermal resistance over there when the rod are connected in series manner, then how you can find out K equivalent over there, and if rods are connected in parallel manner, and if it is given to you length, area, everything same, then how you can relate over there thermal conductivity with the K1 and K2 value. I hope it is okay for you to understand. Thank you.